Hi everyone, welcome to today's GCSE Maths revision video. There's 3 days to go to your GCSE Maths exam, so keep up the hard work, you're doing really well. And today we're going to be doing a recap of the algebra topic. So we're going to recap the algebra topics that come up in your paper in 3 days' time. So let's get started.
Hi, today we're going to recap the algebra topics on the Corbettmaths GCSE Foundation Revision Checklist. So that's all the blue topics, all the topics that are in blue are the algebra topics, and we're going to recap those today. If you want some extra help or a bit more detailed explanation any of the topics, if you go to the Ultimate GCSE Foundation Revision video and you go from 4 hours, 55 minutes and 40 seconds until 6 hours, 47 minutes and 54 seconds, that's where I go through all the algebra topics. But alternatively, in this video, I'm just going to go do a quick recap of all of them. That's what we're going to go through today, so let's get started. So first up was coordinates. It's very important you can plot coordinates, you can plot points, and you can also write down the coordinates of points. So in terms of this point A, its coordinates would be, well, we're going 2 along the corridor, 4 up the stairs, so it'll be 2, 4. The point B here, well, we're going 2 across and then 2 down, so it'll be 2, -2. The point C would be -5, 1, -5, 1. And the point D would be 0, -4. So 0, -4. So it's very important you can plot coordinates, read coordinates, and that you can also answer questions that involve coordinates, perhaps with shapes and so on grids. Okay, next. Okay, next topic, function machines. So you may need to use a function machine like this one. So if you know the input, you would then just multiply by 3 and then subtract 8, and that would give you the output. And then if you're given the output and you want to find out what the input was, then you need to do the opposite. So you're going to then add 8 and then divide by 3. So working backwards. And that's it. Okay, next topic, writing expressions. Now in terms of writing expressions, there's a variety of situations where we may need to write expressions for. So video 16 will be useful for you. So here we've got Jake, he's X years old. Anna's 3 years older. And we've been asked to write an expression for her age. Well, if she's 3 years older, you would add 3 onto his age. So that'll be X plus 3. And then we're told that Beth is 4 times older than Jake. So whatever age he is, you would multiply by 4 to get Beth's age. So if we take our X and times it by 4, that'll be 4X. And that's it. Okay, next. Okay, you also need to be able to collect like terms. So if you're asked to simplify something like this, 8x plus y subtract 3x plus 5y, you would deal with the x's to begin with. You've got 8x's take away 3x's, that's going to be 5x's. And then in terms of the y's, we've got plus y, that's plus 1y, so we've got 1y, and we're adding 5y, so that's going to be 6y's, so plus 6y's. So if we're asked to simplify this, the answer would be 5x plus 6y, and that's it. Okay, next, multiplying and dividing terms. So let's look at multiplying terms to begin with. So 9 times y, well, we've looked at one of those already whenever we looked at formula expressions. 9 times y, just put them together, 9y. 4x times 5, well, let's multiply the numbers together first. 4 times 5 is 20, and then x, so 20x. And then 3y times 2y, well, 3 times 2 is 6, and then y times y is y squared, so that'll be 6y squared. So whenever you're multiplying terms, you just multiply the numbers together, and then multiply the letters together, and then just put it all together at the end. Okay, next, dividing terms. If we had something like this, 12x squared divided by 3x, so the line means divided by. 12 divided by 3 would be 4, and x squared divided by x would just be x, so the answer would just be 4x, and that's it. Okay, next, laws of indices. So if we're multiplying things with the same base, so m cubed times m to the power 4, we add the powers, so that'll be m to the power of 7. If we're dividing things with the same base, m to the power of 8 divided by m squared would be m to the power of 6. We take away the powers. And if you've got a power of a power, so here you get m cubed squared, you just times these powers together, so m to the power of 6. So it's important to know those laws of indices. Okay, next, sequences. So in terms of sequences, you need to be able to find the next terms of sequences. So for instance, if you're given sequences like these, knowing how to find the next term. So here you're just going down by 2, so that'll be 44 and 42. These are the square numbers, so we're adding 3, adding 5, adding 7. So adding 9 would be 25 and adding 11 would be 36, or the square numbers. Here we're adding 1, then adding 2, then adding 3. So then we'll be adding 4, which would be 18, and adding 5, which would be 25. And here we've got our cube numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. And so on. So here we'd have 125, which is 5 cubed, and 216, which is 6 cubed, and so on. Also, you might be given rules to create a sequence. So here we've got a sequence. We'd need to add 40 and then divide by 2 to find the next term, and so on. So if you had 80 and you added 40, you get 120, and then divide by 2 would be 60, and so on. And you just do that to find the next term. So the next one, you take your 60, add 40, which is 100, divide by 2, which would be 50, and so on. Okay, next, you may encounter patterns and so on. So you may need to, here you've got a pattern of dots, you've got this shape and it's just getting bigger and so on. You've been asked to draw a pattern 4. So each time, as you can see, we're adding another dot on top, we're adding another dot beneath and another dot to the left. So you would just copy out pattern 3 and just do another dot above, below and to the left, and that'd be pattern 4. And then the next question is, how many dots will there be in pattern 5? Well, you could draw it and count them out, or you can look at the pattern. So we've got 4 here, we've then got 7 here, here we've got 10. So as you can see, we're adding 3 each time, so we'd have 13 and then 16. So you can just look and see if there's a pattern and so on. Also, you may need to deal with the nth term with sequences as well, and we'll look at the nth term in a minute. As well with sequences, you may encounter triangular numbers. So we've talked about square numbers and cube numbers and so on. So triangular numbers. So in terms of the triangular numbers, let's do our pattern. So we've got a dot, then we've got a dot with 2 beneath it, and then we've got that, then with 3 dots beneath it. And every time you're just adding another row of dots beneath, and they're your triangular numbers. I always sort of think of them whenever I'm doing 10-pin bowling or playing snooker or something like that. So in terms of our triangular numbers, they would be 1, and then we would have 3, and then we would have 6, and then we'd have 10. So we're adding 2, adding 3, adding 4, adding 5, and so on. And that's how you then, if you know your triangular numbers, you can answer questions like this. Okay, next, Fibonacci. So it's important to recognize Fibonacci style sequences. So for instance, if we had 1 and 1, to find the next term of a Fibonacci sequence, we'd add these two together, so that'll be 2. To find the next number, we'd add these two together now, so that'll be 3. Then we'd add these two together, that'll be 5. Then we'd add these two together, that'll be 8, and so on. So you just keep adding the last two terms, you'll get the next one. So 8 plus 13 would be 21, and so on. And that's Fibonacci, and it's useful to recognize those, and also to be able to, if you've got Fibonacci style sequences, so different two first numbers, how you'd work out the next ones, and so on. Okay, next, the nth term. So here we've got 4, 9, 14, 19. As you can see, we're getting bigger by 5 each time. So in terms of numbers that are getting bigger by 5 each time, I'm thinking of the multiples of 5. 5, 10, 15, 20. And so I'm going to write 5n, because 5 times 1, 5 times 2, 5 times 3, and so on. Now our sequence wasn't 5, 10, 15, 20. It's actually one less. We're taking away 1, taking away 1, taking away 1, taking away 1. So the nth term for our sequence would be 5n minus 1. Now this is really useful. We could find the 100th term. We could do 5 times 100, which is 500, take away 1, which would be 499, and so on. Someone may give me a number, for instance, 477. I can tell straight away 477 is not going to be in this sequence because it always ends in a 4 and a 9 and a 4 and a 9 and so on. But you could put your nth term equals to the number, and then if you solve that equation, you can get a whole number, it's in the sequence, but if you get a decimal number, it's not in the sequence, and so on. So the nth terms are really useful, so it's important to know how to work them out and how to use them. In terms of geometric progressions, this is where you're multiplying by the same number each time, so you're multiplying by 2, by 2, by 2, by 2 here. So that's a geometric progression. You can multiply by a half each time, and it'll be sort of halving each time, and so on. So geometric progressions where you're multiplying by the same thing each time. Okay, it's important we know how to expand brackets. So if you've got brackets like this, you just multiply what's inside the bracket by the term outside. So 6 times y would be 6y plus, and then 6 times 7 would be 42. Here, 2 times 1 would be 2, and then minus, and then 2 times 3x would be 6x. Here, x times 3x, well, x times x is x squared, and then we'd have 3 of them, so 3x squared plus, and x times 4 would be plus 4x. And then here, 2y times y would be 2y squared minus, and then 2y times 3 would be minus 6y, and that's it. Also, it's important to know how to expand two brackets. So here, x plus 6 times x minus 2. So we just do x times x, which is x squared, x times minus 2, which would be minus 2x, 6 times x would be plus 6x, and 6 times minus 2 would be minus 12. And then here, minus 2x plus 6x, well, minus 2 plus 6 is 4, so it'll be x squared plus 4x minus 12. So it's important you know how to expand pairs of brackets. So we've looked at how to expand, let's look at factorizing. So that's putting the brackets back in. So if we had 5x plus 20, if we wanted to factorize this, so putting the brackets back in, so we look for any common factors of 15x and 20, and I can see I can divide both of these by 5. So I'm going to put 5 outside the bracket, and then if we divide both of them by 5, 15x divided by 5 will be 3x, and then plus, and 20 divided by 5 is 4. So that's how you'd factorize that, putting the brackets back in, and you can expand to check your answer. In terms of factorizing this, we can divide both of these by 2y. So we would do 2y bracket, and then 4y squared divided by 2y would be 2y plus, and then 6y divided by 2y would be 3, and that's it. So factorizing this would be 2y bracket 2y plus 3. Okay, next, factorizing quadratics. So here we've got x squared plus 8x plus 15. So if you're factorizing this, you can put your two brackets down. Think of when we expanded two brackets, whenever we expanded it, we got something like this. Because of x squared, we're going to put an x in front of both brackets, and then the two numbers in the brackets will multiply together to be 15 and add together to be 8. So that'll be plus 3 and plus 5, because 5 times 3 is 15, and 3 plus 5 is equal to 8. So we're factorized there. In terms of factorizing this, we would do bracket, 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 bracket. We then have x's in the front of both brackets. We want two numbers times together to be minus 22 and add together to be minus 9. So because it's minus 22, the times together to give us, so one's going to be positive, one's going to be negative. And then adding together to be minus 9, I'm thinking minus 11 and 2, because minus 11 times 2 is minus 22, and minus 11 plus 2 would be minus 9, and that's it. Okay, next we've got the difference between two squareds. If you got something squared, take away something squared like this, you can factorize it, use two brackets, you then square root each of them and put a plus and a minus sign in the brackets. So here we would have x and x, the square root of 9 is 3 and 3, and one with a plus sign and one with a minus sign. And if you expand your brackets here, you would get this, and that's called the difference between two squareds. Okay, next. Okay, if you wanted to solve something like this, if you want to solve this quadratic, you just factorize it. So factorize this. and still equal to 0. So then x and x, we want two numbers that times together to be 15 and add together to be negative 8. So because they times together to be a positive and add together to be a negative, they're both negative. And negative 3 times negative 5 is 15. And then if you add these together, you get negative 8. Now we've got two brackets that times together to be 0. So that means that either of the brackets is equal to 0. So one of our solutions will be equal to, well, 3 take away 3 0, so x is 3. And here, if x is equal to 5, that'll be 0, so x equals 5. And there are two solutions, x equals 3 or x equals 5. Okay, next, solving equations. Let's have a look and see how we would solve these equations. So if we want to solve this equation, you would want to get the w on its own. So we want to get rid of this minus 7. So to get rid of minus 7, we'd add 7 to both sides. So if we add 7 to the left-hand side, we'd just be left with 4w, because minus 7 plus 7 is 0. And then 9 plus 7 is equal to 16. So we've now got 4 times w is equal to 16. We don't want this multiplied by 4, so we're going to divide by 4 and divide by 4, and we'll get the w is equal to 4. So that's how you solve an equation like that. And this one will be the same. You just take away 1 from both sides to begin with, and then after that, then you'd multiply both sides by 2 to get rid of this divide by 2. Okay, next, if you've got an equation with letters on both sides, like this one, you get rid of the lowest number of x's. So in this one, we've got 5x and 3x. I'm going to get rid of the lowest number of x's, so the lowest one, which is 3x in this case. So I'm going to take away 3x and take away 3x. And then if you take away 3x from both sides, take away 3x from this left-hand side, it would leave us with 2x plus 1. And on the right-hand side, we'd just be left with 19. And then this is just like the ones before, where we would take away 1 from both sides to get 2x equals 18, and then divide by 2, and you get that x equals 9. Okay, next. Now, in terms of formula solving equations, there's a load of different questions that you may encounter in terms of formula equations. It could be to do with angles and a shape like this one. It could be that you know what the perimeter of a shape is and you've got algebraic expressions for the lengths of the sides. It could be to do with ages. It could be anything really. So if you have a look at these videos and practice questions, they'll be useful for you as well. Now, in terms of this question, if we were asked to find x here, what we would do is we'd have to form an equation. And because this is an isosceles triangle, these two angles are the same. So here we've got our isosceles triangle of a line of symmetry. So these two angles are the same. So if this angle is x plus 20, this angle here would be x plus 20. And now we can form an equation because we know that these three angles must add together to be 180. So 2x plus x would be 4x's. And then we've got plus 20, that'll be plus 40. And then that's equal to 180 because the angles in a triangle add together to be 180. And then you can just solve this. We could take away 40 from both sides, and that would leave us with 4x equals 140. And then we could divide by 4 and divide by 4 and get the x is equal to 35 degrees. And that's it. Okay, that's how you'd form and solve that equation. And as I said, these practice questions and videos will be very useful for you. Okay, next, solve an inequality. So you may encounter an inequality like this. 3x plus 4 is less than or equal to 31. And you solve this just like an equation. So take away 4 and take away 4. And you get that 3x is less than or equal to 27. And then divide by 3 and divide by 3. And you get that x is less than or equal to 9. And that's it. That's how you'd solve that inequality. Okay, next. Sometimes you might need to show inequalities on number lines. So for instance, if I wanted to show the inequality x is bigger than 1 on this number line, I go to 1. And if it's just bigger than, you do a hollow circle. And then because it's bigger than 1, you just do an arrow to the right. So that's x is bigger than 1. If you wanted to show that x is less than or equal to 2, because it's less than or equal to 2, you go to 2. And because it's less than or equal to, you do a shaded in circle. And then it's less than or equal to, so it's an arrow to the left. So that would be x is less than or equal to 2. And just remember, if it's bigger than or less than, you do a hollow circle, or it's less than or equal to or bigger than or equal to, you do a shaded in circle, and then you just do the arrow to whichever way you need to do the arrow. Okay, next, you may encounter inequalities like this, where you get 7 is less than 2 and it's less than or equal to 14. And you've been asked to list all the integers that satisfy this inequality. So if you've got an inequality like this, you could just divide everything by 2, because we want to find out what n is, the number. So if you divide everything by 2 here, you get 3.5 is less than n, which is less than or equal to 7. And then it's integers, which means that it's going to be numbers such as minus 7 or 5 or 4 and so on. So in terms of the integers, 4 would work, 5 would work, 6 would work, and it's less than or equal to 7, so 7 would work as well. And that's it. So they're the integers that would work for that inequality. Okay, next you may encounter conversion graph. So if you get a conversion graph, you may have one drawn for you and then you just need to use it, and that's fantastic. But you may have to draw it first. So here we're given that 1 kilogram is approximately equal to 2.2 pounds. So let's draw a conversion graph. So I know that no kilograms is equal to no pounds. I can plot that one to begin with. Now I'm not going to do 1 kilogram here because it's a bit hard to read. What I'm actually going to do is I'm going to times both of these by 10. So 10 kilograms is approximately equal to 22 pounds. So 10 kilograms is approximately equal to 22 pounds. So that's exactly there. Each of those little lines is worth 2 because 2, 4, 6, 8, 10 to get to 10. So that's going to be 22 there. And that means that 20 kilograms, if we double those, will be approximately equal to 44 pounds. And then if you're asked to use that conversion graph, so for instance, if the question said, use your conversion graph to work out how many pounds is in 15 kilograms, you go 15 kilograms up and across and read off that number, a bit like scatter graphs. And if you're asked to, for instance, write down how many kilograms 50 pounds is, you go to 50 pounds across and down and read that off. If they said, for instance, change 400 pounds into kilograms, well, there's not 400 pounds here on the axis, so we'll probably do 40, get what that is, and then times it by 10 to find out what 400 pounds would be, and so on. So that's how you use conversion graphs and draw them as well. Okay, next, drawing linear graphs. So I'm actually going to start off with this one. If we were asked to draw the graph of x equals 2, there are all the coordinates with an x coordinate of 2, so all those points would be along this line here. So this would be the line, because they're all 2 across and 1 up, 2 across, 2 up, 2 across, 3 up, and so on. So that would be the line x equals 2. So if you've got an x equals graph, x equals 4, that'll be a vertical line going through 4. If you had x equals minus 3, that'll be a vertical line going through minus 3, and so on. Now, if we wanted to draw y equals negative 1, we would draw a horizontal line through negative 1 on the y-axis, because all of these points would have a height of minus 1, so it would look like this. So that would be the line y equals minus 1. If you're asked to draw y equals 3, it'd be a horizontal line going through 3 on the y-axis, and so on. So it's important to be able to draw those x equals graphs and y equals graphs, not only for this topic, but also for reflections, because you may often have to draw the mirror line. And then if I want to draw this graph, y equals 2x plus 1, the approach I probably would use is I'd probably just use a little xy table. I would choose some values of x, 0, 1, 2, 3. And to find the y coordinate, we multiply all the x coordinates by 2. And then add 1. So if we multiply this by 2, 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. And then you just plot those points. And that would be it. That would be the graph of y equals 2x plus 1. And that's it. Now there is another approach, and I'll talk about that in a second. That's where you use the gradient and the y-intercept. So I knew that this graph was going to cross the y-axis at 1, and it's got a gradient of 2, where you go across 1 unit and up 2 units, across 1 unit and up 2 units, and so on. Okay, so in terms of that, y equals mx plus c. So this is the equation of a line, y equals mx plus c, the equation of a straight line. So m's the gradient, how steep the line is, and c is the y-intercept. So if we had a look at this line here, this diagonal line here, its y-intercept is equal to 1 because it crosses the y-axis of 1, so it'd be plus 1, as you can see. In terms of its gradient, to work out its gradient, you do rise divided by run. So you choose 2 points on the graph, you draw a little triangle like this, and you work out the run. So as you can see here, we're going 2 across, and we're going up 4 units. And if we do 4 divided by 2, that's equal to 2. So the steepness of this line is 2. As we go across 1 unit, we go up 2. As we go across 1 unit, we go up 2. So its gradient is 2. So it's y equals 2x plus 1, and that's it. So that's the equation of that line, y equals mx plus c. So here we've got a line. Let's find its equation. So its equation will be in the form y equals mx plus c. It crosses the y-axis of 4, so I know it's going to be plus 4, so it's going to be y equals something plus 4 because it crosses the y-axis of 4. Let's find its gradient. So to find its gradient, let's choose 2 points. I'm going to choose this point here, and I'm going to choose this point here. And to find its gradient m, it's equal to rise divided by run. How much you rise, how much it goes up, which is 1, 2, 3, 4, 5, 6 units. And I'm just checking, I'm going from a height of 1 to a height of 7, so that's 6. So I'm not counting the squares, I'm counting the units. I'm going from 1 to 7, so I'm going up 6. And in terms of the run, I'm going from negative 1 to 1, so I'm going across 2. So I'm going across 2 there. And then if I do the rise 6 divided by the run 2, 6 divided by 2, that's equal to 3. So it's going to be equal to y equals 3x plus 4. So that's the equation of that line. Okay, and next, gradient. So we've talked about gradient. Gradient's found by rise divided by run. And it's important to be able to draw those little triangles and work out the rise, so how much it goes up, and then the run, and do the rise divided by the run. And then if the graph's going downwards, it won't have a positive gradient, it'll have a negative gradient. So if the line's going down, you're going to have a negative gradient, and that's it. Okay, so you may also encounter straight line graphs in real life situations. So here's the cost of hiring a bouncy castle for a number of days. So we've got 0 days is £100, so that's like a set fee, a set charge for hiring the bouncy castle. And then we've got 2 days is £150, 4 days is £200, 10 days is £350, and so on. So you maybe ask questions involved in these. For instance, how much does it cost to hire the bouncy castle for 5 days? So you go 5 up and across and see that's £225. You may be asked the question, how much is the set charge for hiring the bouncy castle? Or perhaps the delivery charge or the setting up charge or something like that. And in this case, it's £100. And you can find that by going to 0 days and seeing that number. And you may also be asked to find the cost per day. And you can do that in a couple of ways. One approach is to find the gradient of the line. So to find 2 points, such as this point and this point, and do your rise divided by run, so turn it into a little right angle triangle, and do the rise, which is £250, it rises £250, and the run is 10 because it's 10 days, and 250 divided by 10 is £25, so it's £25 higher per day because the gradient of the line is 25. Or you can just have a look and see that for an extra day it's £25, another day it's £25, another day it's £25, and so on. So that's how you'd answer those questions involving real life graphs. Okay, next, parallel lines. So we talked about y equals mx plus c. If lines have got the same gradient, they've got the same steepness of each other, so that means that they're going to be parallel. So the line y equals 2x plus 1 and the line 2x minus 3 are parallel lines because they've both got a gradient of 2. And as you can see, they've both got a steepness of 2, so they're parallel to each other. So parallel lines have got the same gradient. Also, another topic you may encounter is substitution. So you may be given some values, so w is equal to 9 and y is equal to 5, and you may be asked to find the values of things such as 8w minus 3y. So to do that, you would do 8 times w, and 8 times 9 would be equal to 72. Subtract, and then 3y, and 3 times y, 3 times 5 is 15, so subtract 15, and then you just work this out, and that's equal to 57. So it's important you can substitute values into expressions and work them out. And if you want some more practice, beside video 20, you've got some practice questions there as well. Okay, and in terms of substitution, you may also be given situations in a bit of a context. So here we've got Erin's cooking a turkey. This isn't an accurate formula, by the way, so don't try and use it to cook a turkey. But we've got the cooking time is equal to 90 plus the weight of the turkey in kilograms times 20. And the question says, how long should it take to cook a 7 kilogram turkey? So the weight of the kilogram is 7, so you're going to do 7 times 20. Remember your Bob math, 7 times 20 is 140, plus 90 would be equal to 230. So that would take 230 minutes. You may also be given a question where you're told the cooking time and you need to find the weight of the turkey. And in that case, you can work backwards. So you could take away 90 and then divide by 20, or you could set up an equation and solve it. And that's it. Okay, next, changing the subject. So sometimes you're asked to make a certain letter the subject of something. So here we've got t equals aw subtract c, and we've been asked to make w the subject, so that means you want w equals, so it means that you want to get rid of everything else on this side, this right hand side, and just leave w. So let's get rid of the minus c to begin with, so let's add c to both sides to get rid of this minus c. T plus c would be t plus c, and on the right hand side you're adding c to get rid of the minus c, so you just be left with aw. This is now a times w. You don't want this multiplied by a, you just want to get the w, so we're going to divide by a and divide by a. T plus c divided by a, well, it's going to be t plus c and then divided by a, and that's equal to w. And that's it, we've made w the subject. W equals t plus c divided by a. So it's a bit like solving equations, but you don't actually have to work anything out, so I actually like changing the subject. Okay, next, simultaneous equations. So if we want to solve simultaneous equations like this, what we'd want to do is eliminate one of the letters. So here what we could do is we could times the top equation by 2 and the bottom equation by 3, and that would give us 6x and 6x. And then if we take 6x away from 6x, we're left with 0, and so that means that it's eliminated. Or what we could do is we could just times the top equation by 3 to get minus 3y and 3y, because minus 3y plus 3y is 0. So in terms of simultaneous equations, you want to cancel out one of the letters. So I'm going to times the top equation by 3, so that'll give me 9x minus 3y equals 69. And then we've still got the bottom equation, which is 9x plus 3y equals 8. Now we wanted to cancel out one of the letters or variables, and here what we're going to do is we're going to cancel out the y's, because minus 3y plus 3y is 0. So let's add these two equations to each other. So let's add 9x plus 2x is equal to 11x. Minus 3y plus 3y is equal to 0, so that's just 0. And then we've got 69 plus 8 is equal to 77. And then you just solve that, divide by 11, you get x equals 7. So you get x equals 7. And then I'm just going to take the x equals 7 and substitute into one of the other equations. So I'm going to substitute into this bottom one. 2 times x, so 2 times 7 is 14. So I'd have 14 plus 3y equals 8. So 14 plus 3y equals 8, and then if we solve this we can find y, and then we'll find our x and our y. So if we take away 14 and take away 14, we get that 3y equals minus 6, and divide by 3 and divide by 3, and you get that y is equal to minus 2. And then you can check this if you substitute these both into the top one and substitute in x equals 7 and y equals minus 2, you should get 23 as the answer, and then you'll know you're right. Okay, you can also solve simultaneous equations graphically. So here we've got y equals 3 minus x and y equals 2x minus 3. If you draw both those lines, and where those two lines cross each other will be your solution. The x coordinate will be the value for x, and the y coordinate will be the value for y, and that's it. So to solve simultaneous equations graphically, just draw the lines and write down where they meet each other. Okay, next, quadratic graphs. So quadratic graphs is very important. You can draw a quadratic graph. So you may be given an equation such as y equals x squared plus x minus 4, and then you're asked to draw the quadratic graph. And you may have an xy table, perhaps even with some of the values filled in for you, and that's quite nice. And then, so here, if we wanted to work out the y coordinate, so we're going to take the x coordinate. So here we're going to take 3, we're going to square it, we're then going to add 3, because we're adding x, and then we're going to take away 4. So we do 3 squared plus 3 minus 4. 3 squared is 9, so you've got 9 plus 3, take away 4. 9 plus 3 is 12, take away 4, that's equal to 8. So this would be 8. You would then do 2 squared plus 2, take away 4. 1 squared plus 1, take away 4. 0 squared, which is 0, plus 0, take away 4, which would be minus 4. You would then do minus 1 squared. Remember, a negative times a negative is a positive, so minus 1 squared is 1. Adding minus 1 means you're going to go back down 1, which would be 0, and then take away 4, which would be minus 4. So negative 2, you would do negative 2 squared plus negative 2, take away 4. 4 plus negative 2, well, going down 2 would be 2, take away 4 would be equal to negative 2. So it's going to be negative 2 and so on. And I've just filled in the other points as well. And then once you get your points, just plot them. And that's it, that's our quadratic graph. And in terms of our quadratic graphs, they'll have that U shape. If it's an x squared quadratic, it'll have a U shape. If it's a minus x squared, it'll have an N shape. So it'll have that U shape or N shape. And it'll have a line of symmetry as well. And actually we can see that with our points, minus 4, minus 4, minus 2, minus 2, and so on. And that actually can sometimes help you to fill out the table. And that's it. Okay, next, cubic graphs. If you had the graph of y equals x cubed, you just do 2 cubed, which is 8. 1 cubed, which is 1, 0 cubed, 0, minus 1 cubed, which would be negative 1 times negative 1 times negative 1, which is negative 1, negative 8, and negative 27. And then once you plot your points, you do a curve through them. And that's it. That's my curve is the best I can do there. So that's the graph of y equals x cubed. If you had the graph of y equals minus x cubed, it would look the same, but the other way around, it would come down that way. And that's it. Okay, and you may also encounter reciprocal graphs, and that's where you've got, for instance, here we've got y equals 2 over x, where the x is on the denominator. So you just need to, whenever you substitute in the values for x, you're going to do 2 divided by 5, 2 divided by 2, 2 divided by 1, and so on. So let's work those out. And that's it. And the curve will look something like that. Now, apologies, not necessarily the best one. I'm trying to do this on the computer. It should be a nice smooth curve through those points. The graph will approach the x-axis but never reach it, and it'll approach the x-axis there and never reach it, and likewise it'll approach the y-axis and never reach it as well. And that's the reciprocal graph. So these are the topics we've gone through today. We've looked at coordinates, so knowing your coordinates are along the coordinate upstairs. Make sure you put your brackets around your coordinates and put your comma in and so on. And make sure you also know how to plot coordinates and read them, and also to know how to answer questions that involve shapes on grids. Function machines, so if you've got the input, you just go through the function machine to work out the output. And if you know the output and you want to find the input, you go backwards and make sure you're doing the inverse operations. Writing expressions, so make sure you know how to write expressions and do things such as 2 times x to be 2x, x squared to be x squared, x divided by 2 would be x over 2, 2 less than x would be x minus 2, and so on. Know how to collect like terms, so I would actually go through and perhaps deal with the x's and then deal with the y's and so on. Know how to multiply terms and divide terms. Know your laws of indices, so whenever you're multiplying things with the same base, you add the powers. Whenever you're dividing things with the same base, you take away the powers. And when you've got a power of a power, you times the powers. Sequences, know how to find the next terms of sequences, know how to find missing terms, know your triangular numbers, know your Fibonacci sequences, so whenever you add the 2 previous terms to get the next term and so on. Know and also how to deal with questions that involve patterns as well. Know how to find the nth term, so see what it's going up by and write those multiples beneath, and then figure out what you need to do to those to get to the sequence, or perhaps add something or take something away. Also, if the sequence is going down, write the minus times tables and then think what you need to do to those to get to the sequence. Expand in brackets, so just multiply what's inside by the term outside, or if you got 2 brackets, so multiply both of the terms by the first term in the bracket, and then multiply both of the terms by the second term in the bracket, and then simplify. Factorizing, make sure you can factorize by thinking on what they can both be divided by. Take that outside and then divide to find what goes inside the brackets. Factorizing quadratics, and with GCSE foundation, it'll always be an x squared quadratic, so the 2 numbers in the brackets will times together to be the thing on the end, and they'll add together to be what goes in front of the x in the middle. Know your difference between 2 squared, so if you've got something squared, take away something squared, you'll do the brackets, you'll square root both things to find what goes in the brackets, and you do one with a plus sign and one with a minus sign. Make sure you know how to solve equations. Also make sure you know how to deal with letters on both sides, and also solve quadratic equations as well. Also forming equations, make sure you can form equations. Perhaps it might be to do with perimeter, it might be that you've got a rectangle and you know then the opposite sides have got the same length and you can form an equation that way. It might be to do with angles, it might be to do with ages or money or something like that. Practice those if you can. Inequalities, make sure you know how to draw inequalities in number lines, how you can solve inequalities and so on. Make sure you know how to draw conversion graphs and use conversion graphs. Draw linear graphs, so the XY tables can be quite useful for those, and also know the x equals graph. So for instance, x equals 3 would be a vertical line going through 3 in the x-axis. If you had y equals minus 4, it would be a horizontal line going through 4 on the y-axis, and so on. Y equals mx plus c, know that m stands for the gradient, and then c stands for the y-intercept, to know how to find that gradient and y-intercept. So the y-intercept is found by finding where it crosses the y-axis, and the gradient you find by doing rise divided by run. Real life graphs, and knowing what that y-intercept will represent, perhaps the set phi, the set charge. Also, the gradient would be something perhaps like the charge per day or the charge per hour, something like that. Parallel lines, know that the parallel lines have got the same gradient. So if you've got y equals 5x and y equals 5x plus 1, they'll be parallel lines. Substitution, know how to substitute values into expressions. Be particularly careful with negative values whenever you're substituting them in. You know, if you're doing subtracting a negative, you're going to be going back up and things like that. Changing the subject, so you approach that in a similar way to solving equations, but at least you don't have to work anything out, which is pretty cool. Simultaneous equations, so being able to solve simultaneous equations. So perhaps you need to multiply one of the equations by a certain number to be able to eliminate the x's or y's, or even multiply both of the equations by numbers to be able to eliminate the x's or y's. If both of the letters are positive or both of them are negative, you subtract the two equations. If you got one that, with, for instance, negative 4y and plus 4y, then you'd add them together to get 0. So adding those together would eliminate those. And then whenever you find the value of one of the letters, get that value and substitute it back into one of the equations to get the value of the other letter. And then also you can check it, which is pretty cool as well. Quadratic graphs, knowing how to plot and draw quadratic graphs. So being able to get those points in the XY table. Be careful with those negatives. Be able to plot those points and find those U-shaped parabolas or N-shaped parabolas. You might be asked to find where it crosses the x-axis or y-axis. You might be asked to find the coordinates of the minimum point, that lowest point of the graph, or the maximum point of the graph, and so on. And also know the shapes of the cubic graphs and reciprocal graphs and how to plot those as well. And that's it.
And that's it. So in this video, we've done a recap of the algebra topics. Now, we've gone through the number topics, we've gone through the statistics topics. Today, we've gone through the algebra topics, and tomorrow we'll go through the geometry or the shape, space, and measure topics, and we'll look at those tomorrow. And that's it. So thanks very much. I really hope you found this video useful, and you've got 3 days to go. Keep up the hard work. You're going to do really well, and I'll see you tomorrow. Cheers. Bye.